There we go. Okay. So in there, on your piece of paper, we're just going to make a summary of the things that we have to know. Okay? So the topics that are included, we have to be able to know all the parts of a computer. Okay? So we have hardware. Okay? This includes parts of the computer. You need to understand what it looks like and the function. Okay? It also goes into the different ideas of storage. It also goes into the operating systems. Was there anything else, Ched, that we studied about hardware? We did, before I had a computer, and you had to be able to identify from a picture about where's the CPU, the graphics card, the RAM, the ROM, things like that, the EEPROM, and you have to understand what he does. Was there other topic that we did? I think that those are the topics for the hardware. Okay? Then what we did is we had software. What did we study in software there, Wendy?
Like system software, application software.
Yes, we did system, which are basically operating systems and things like that, the important ones, and utilities. And then we did application. Okay, very good. What was the third topic there, Uma? What did we study? After software, what did we study? This is a unit that we took about 3 weeks on it. After we did software, what did we study? Oh, there's one more topic in software. What did we study at the end of the software unit? Yeah, we did do assembly, and we also did copyright, the rights. Do you remember freeware, open source? This will also be on the test. And then, as Uma said, yes, we went into the CPU architecture. In the CPU architecture, we did logic gates. We did logic gates, and then we did the assembly. Was that it? I think that's where we ended. We finished with assembly language. Okay, so this is what the test is going to be on tomorrow. Okay, we also had some programming. We do have some programming. Wendy, tell me what's from the last 2 weeks, what were we learning in Python?
Loop and string.
We were learning about loops, the for and while loop, and we will learn string. There's going to be one question about programming, but the majority of the questions are going to be hardware, software, and assembly language. Copyright, maybe in some like multiple choice question. It won't be too big of a that. Is that clear about the topics for the test tomorrow? This test is going to be a little bit longer because we're preparing for our mock exams, and our mock exams are happening after the holiday.
So I copy it.
So you can copy this, yes. Yes, please copy this. Okay? So these are the topics: hardware, software, CPU, and copyright. Now, we're just going to have a quick review about parts of a PC. Can you identify these parts right here? I'm going to choose one. What is HDD, Wendy? What is HDD?
Hard disk drive.
Yeah, hard disk drive. Describe inside a hard disk drive, what does it look like? If you were to take it apart, do you know the parts of a hard disk drive? Do you know the parts inside a hard disk drive? So inside a hard disk drive, you have these things called platters, right? Yeah. So you should know a little some more detail in there. In the platter, we have magnetic. It's basically you have a head. We call this a read, write, head. And this is a mechanical device because he will change the magnetic metal oxide on these platters. Okay? And this is an older technology. So if you drop it, the platters could break. And also it's a little bit slow because the read-write head has to go to a specific sector. Uma, what is a sector? Have you heard about hard drive sectors? So sectors are basically a specific area on the platter. And those are called sectors. And so when you save a program, it's going to be stored on a location, on a track. But a group of tracks where it writes is called a sector. And there's this utility program called defragmentation, where they actually can move the data of a program to one location, so it makes your hard drive a little bit faster. Okay? So you should know a little detail about that. Now we also go into the RAM. Okay, I'm just going to scroll down. Okay, by the way, this will be on the OneNote. So if you want to have a look, it will be also there, chat. Okay, so we're going to talk about the hardware. Okay. So hard drive is basically you have a whole bunch of platters, and then you have a little head. Okay, you have a read, write, head. Okay, what else did I say? What is the area called there, Uma, when you save? What is this called? An area where you save is called sectors. Okay, a sector is an area of data. And if you just save on a specific line as it's spinning, this is called a track. Okay? So this is kind of like an old hardware. Now, we have a new hardware. It's called SSD. SSD is more like a USB. Okay? SSD is new. It's a new type of hard drive. And it uses flip-flops. If you remember Boré, he did his hardware project presentation about NAND, right? NAND logic. And on solid state drives, you have these NAND. What is NAND? Is a logic gate, NAND gate. So it uses flip-flops. And this is something that you study in grade 12. So when you will be studying about the flip-flops. Okay? It has no moving parts. Okay? It's fast. It's expensive. But it has no moving parts. No moving parts. So that means that it's more stable if your laptop, almost all laptops have this solid state drives because they're very thin and fast and but they're more expensive, right? They don't have as much space, okay? They're expensive, they have no moving parts, so if you drop your laptop, they won't break, okay? So this is all about the storage device. Also, we talk about the RAM and ROM, okay? So right here, you should know about memory and storage, and that's basically what we have here. This is just a little detail about the hardware, but then you should understand the overview of this. Is orange okay, or do you want me to go black? Is black better? What is easier to read? I can't tell. Numa, what is easier for you to read? Black or orange? Black? Okay. So
Can you send me the PowerPoint?
yes.
I can't see it.
Yes, I will. I have it on Teams.
Can I put it on my laptop?
Yeah. Yeah. So you can actually open up. Let me think about this. I'm going to be drawn here. You can actually open up on your laptop. You can go into unit number 2, and it's at the very end. It's called Unit 2 Review, and that's what I'm doing this in real time. Okay. So, Ched, if I'm writing too fast, what you can do is go right now and open up your laptop to OneNote that I showed you yesterday, and as I'm writing here, it should pop up on your laptop. Yeah. Okay. So we're going to show you the overview of. I'm just going to make this a little bit. You don't really need this information because I'm going to write it over here. Okay, storage. Again, this is in hardware. Storage has 2 types of storage. Okay? We have primary, and then we have secondary. A computer must have primary data to boot, to load into BIOS. But if you remove your primary storage, it will not even turn on. It will give you a beep code. It'll go beep, beep, beep. It'll say you're missing the RAM. Or if there's something wrong with the ROM, it'll say no, your computer will not work. That's what we call it primary storage. It's the most important. The second thing is hard drive. Do you need a hard drive for your computer to turn on, Wendy?
Yes.
No. Your computer will still boot, it'll turn on, and it'll go into BIOS, it'll still turn on, it'll show the logo, it will still turn on without the hard drive. But it'll say, sorry, you do not have hard drive, it'll give you an error code. The computer will still work. You could put a USB and you could still go into C prompt, it'll still work. But it won't go into Windows, because Windows is stored on the hard drive. But you don't need secondary storage for your computer to turn on. Okay? Primary storage, there are 2 types. RAM and ROM. And then secondary storage, we have hard drive, okay, which we already talked. This is the old technology. Then we have SSD, solid state drive. We already talked, it's made from flip-flops. What other things? We have magnetic tapes. Discs, like a floppy drive. This is old, okay? We briefly talked about it, but it's basically like a USB, okay? We also have like external USB. Okay, we installed Linux on a USB. We also have CD, a CD drive. Okay, and then there's also the last one is called cloud. It's online. Okay, now a key thing to know is there's another word for CD. CD uses a laser to write. Okay. This is called optical storage. Okay, I'm just putting some important thing. Now, RAM, is it volatile or non-volatile? Do you know what volatile means there, Ched? Do you remember? Volatile, non-volatile? That's it? Nijiraman?
No.
No, what is volatile? What is non-volatile?
When the data is lost if the power supply is gone.
Correct. What one is volatile, ROM or RAM? What one loses this data when there's no power?
RAM.
Yeah. So this is called volatile. So I'm just putting this in orange because this is a keyword that you must know. Volatile. Sorry, it should be A. And then ROM is non-volatile. What does that mean, Wendy?
The data in ROM is constantly exist.
Yeah, it means it's like saved on the ROM chip. In fact, the reason why is there's actually a little coin battery. There's a 3-point coin cell into the motherboard, and so that you don't lose your time on the thing. Okay. So we need to know, I'm going to focus now, this is the overview of the different things. That's clear? We need to focus on the idea of RAM and the ideas of ROM, okay? So on your page, you're just like making a mind map. I'm just writing the important information, okay? The other stuff we don't need to write, okay? Again, you'll have access to all this material. It's on the OneNote. So if you have your computer, it'll be at the end of Unit 2. And if not now, I can show you how to find it later. So let's zoom in, and we need to talk about RAM. What does RAM stand for? Chen? R for what?
Remember.
No?
Random.
Random. Very good. A?
And
You can look in your notes. Wendy? A. AM.
Random access memory.
You are correct. Random access memory. What is the purpose? What is the function of RAM, Uma? Why do I have RAM? What does he store?
Stores the temporary.
Give me an example. When I start on my computer, what are some things that store in RAM?
The BIOS.
No. BIOS is in
ROM.
the ROM, yeah. What is the very first thing that loads into RAM when you start my computer? What is the very first program? It shows you the Apple logo, and then the next program that opens is? It's not BIOS. BIOS is stored into, after BIOS is activated, it's going to... Yes. The very first thing that it's used for is to load your OS system. That is the very first thing that goes into RAM. And then any program you activate or open will go into RAM. RAM is like a table. It's like a work table. Okay? And it looks like that little green stick. And it's really close to the CPU. Why is it very close to the CPU? There, Wendy. So if you look into any computer, you'll see that it's really close to the CPU. Why is RAM close to CPU?
Quickly send the data to the CPU and do the calculations.
That's right. The RAM is close to the CPU because all the operations of the von Neumann architecture, all the assembly code is stored in the RAM. Agree? And so it is close to the CPU. And it's like a table. So the bigger the table, you have more space to put more information to work on. If I increase my RAM, will the speed increase? What do you think there, Ched? If I add more RAM to my DNOP, will my computer go faster? Will it be able to boot faster? Will it be able to load program faster? If I add more RAM, what do you think there, Ched? Right now I have 5 GB of this Native. If I add more of this, will this increase the speed of my computer?
No, just increase the storage space.
In fact, it will increase the speed of my computer because the computer will be able to work faster because it has more storage. But there's a catch. If I add too much, if I have too many tables, there's a point where the CPU cannot catch up. Okay? And so adding RAM will increase the speed to a point. Usually computers are at 32 gigabytes of RAM. Because if you add, the speed will increase. But if you add too much, there's little to no benefit. Okay? This is the speed. If you add the RAM, if you add more and more RAM, the speed will increase to a point. It will increase to a point where it will not benefit the system. Okay? And so if you only have 8 GB of RAM and I increase to 16 gigabytes, your computer will probably run faster for today's programs. Right? But if I go up to 64 GB, probably not so much. It depends on what games you're playing and things like that. Now, if I don't have enough RAM, what can I do there, Uma? Have you heard this word called virtual RAM?
Yeah, virtual memory.
Yeah. Virtual memory. What is virtual memory?
If there's new data that needs to be stored in RAM, then the not used data will be moved to a hard drive so that the new data can be transferred.
You are correct. Virtual memory is if I don't want to go and buy this costs money, right? So instead, virtual memory is when you use a part of the hard drive as RAM. Write this down. Is you use a part of the hard drive as RAM. This works, but the hard drive there, Wendy, is the hard drive close to the CPU? Usually the hard drive, the older ones were quite far away. And so hard drives are not as fast as RAM. Agreed? RAM are as fast. And so the read-write time of virtual memory has a problem. What is the problem there, Wendy? What do you think? There's a problem with virtual memory. Is virtual memory as fast as RAM?
I think yes.
No. RAM is faster than the hard drive. Okay? So, the issue with virtual memory is this thing called thrashing. Thrashing is an issue when you're reading and writing to the hard drive back and forth, and it's a little slow problem. Okay? Thrashing is the read-writing to the hard drive. And it's an issue to do with the speed. Okay? So there is some issues with virtual memory. Thrashing is when your RAM is full, you have to store on the hard drive, and that read-write between hard drive and the RAM gets a little bit bogged down in your system. Cool? Okay, RAM. I'm going to ask each of you one question for RAM just so that we can check this off. Uma, tell me one thing that you learned about RAM. Tell me one thing.
It stores parts of the OS.
Okay, very good. Tell me one thing about RAM. I'm just doing a check about your understanding of RAM. Tell me one thing you learned about RAM, or you know about RAM. Tell me.
For storage and memories.
Good. Tell me one thing that you know about RAM.
RAM is close to CPU and easy for CPU to calculate.
Okay, RAM done. You guys are good. 100% on the test. Okay. Now, ROM. I'm gonna put a little star on ROM because he's an important one. He's an important one. Tell me does ROM stand for there, Ched? R-O-M. What does ROM stand for?
Random.
Butcher random.
Regular.
Look at your notes. This is review. Look at your notes.
And common kind with
Oh no.
too much.
Wendy, look in your notes. What is?
Read only memory.
Yeah, it's read only memory. And read only memory is this true? Can I write to ROM there, Uma? Can I only read? Why do they call it read only memory? Can I write to ROM?
No, you can't edit it, you can only.
Are you sure?
Yeah, it's read only.
In fact, it's a lie.
Okay.
The idea is that normally you don't write to it. Normally, we just leave him alone. But ROM you can change. Okay? ROM you can change it in the BIOS. You can boot your computer and say, normally I want to boot to the hard drive. In the BIOS, it's about booting. Booting is when you load your operating system. Normally your operating system is stored in the hard drive. Agreed? And in the BIOS, it'll say the operating system is located on hard drive. I want to boot from hard drive. But if I go into BIOS, I can boot from a USB. And we did this when we loaded Linux. You remember we put USB and we didn't boot to Windows. Instead, we booted to the USB, right? So, read-only memory just means that when I turn off the computer, the data will not be lost. Tell me something that's inside here, inside the ROM. We have the BIOS. What else do we have inside that is that we save? Wendy, what else is in BIOS? In the ROM. Tell me something else that is saved. The important thing for starting the computer.
The core data.
Yeah, tell me some core data that we need to have. We can't change these datas. Because normally, what kind of data there, Uma, is in there? Do we have PROM, EPROM, or EEPROM? In normal computers, what kind of ROM do we have? Do we have PROM, EPROM, or EEPROM? We have EE, and it's electrical erasable. Erasable means you can change. Okay? We can change it. It's a little funny, it says read only. It just means that we're going to very seldomly change it. Okay, in the ROM, what is this right here? Chet, what is this?
RGB color.
Yeah, and it's a clock. Does your computer have a clock?
Yeah.
Yes. So inside the ROM is your time. Where's the time stored there, Uma? Not in the CPU. Where's the time stored? When you turn off the computer, does the time lose itself? Where is it saved? Where's the system time? Yeah, Uma? So right here, the ROM stores the system time. Ched, do all computers have the same time? If I have a computer in China and I have a computer in the UK, will they have the 一样的时间? Will they have the same system time?
No.
No. So should I be able to change the data, Wendy? Yeah.
Yes.
If I go to the UK, I'm going to have to change the system time. I can go into BIOS and change it, and I can also do it with software on my Windows. Windows, when you change the system time, it actually will save it to the ROM. How do I know? Because when I turn off the computer, when I turn it on, it has the correct time. If there's this little coin battery inside my computer, I can show you. Instead of me just talking, I want to show you. Right here, can you see there's this little battery right here? Right here is right beside the, see that little coin battery?
Yeah.
See that little coin battery right here? That is right beside the ROM. It's this little black chip. And this little black chip, he needs a little bit of power. He only needs 3 volts. He needs about 3 volts. Okay, we have a little coin battery. And what this means is the system time, you can go into BIOS and change. Okay, you can press F12 or whatever. It also has the drivers. Do you know what drivers are? They're, Wendy? Drivers are like when I have an input device, like USB, right? Drivers are like, it tells me if I have a keyboard, the type of keyboard. It tells me my CPU architecture.
This is just like the input devices.
Yeah, it has the input devices and things like that. So those are used for drivers, okay? Drivers are also part of the ROM. Okay, is that clear? Now, in ROM, we actually have 3 types of ROM. Okay? I'm just going to quickly write down the 3 types of ROM. So, ROM, let me just go here. We have 3 types. We have PROM, EEPROM, and we have EEPROM. We have 3 types. This is the AS level, okay? In the IG level, you guys just know ROM, okay? It's used for booting, it's for drivers, it's for BIOS, and it has post. It has these booting up things. But for you guys, you should know the difference between the different types. PROM is programmable read-only memory, and this can only write once. So this right here, just write your little note, it can only change one time. In the factory, they just put in the data, done. Computers don't usually have PROM. Not like the laptops, okay? Maybe you have a microchip, okay? But they still have. Now, we have the second type. The second type it's not very common as well. It says erasable programmable read-only memory. And this is a little chip and it has a little light sensor. You can change the PROM by using some light and then you can rewrite it. Okay, maybe you change some hardware parts on the computer, you would have to rewrite the EEPROM. Okay, this uses UV light to change. It can still change. It says read only. It does not mean you can only read. You can write to that. Because today, the most common ROM in your computer is electrical erasable programming read-only memory. Okay? In this case, this is today. You can change the data in BIOS. You can change the setting in BIOS. BIOS stands for basic, sorry, I didn't spell BIOS right. Basic Input-Output System. Let me just go back here. Change in Bias. Okay? Bias is that small program that is inside that chip, and you press like F12 and you can boot into bias and you can change where you want to boot to. I want to boot to my hard drive. I want to boot to USB. Okay? All you have to remember is EEPROM is ones. PROM is ones. EEPROM uses UV light to program. And then the last one is electrical erasable read-only memory, which you can change in BIOS. Okay, I'm going to ask a question. Wendy, which is the most common ROM today in your computer and why? And why?
EEPROM.
Yeah,
Because it's the most modern one and erase more easily like that.
Yeah, it's because sometimes we want to change the system, the time, right? And we go to a different country, we want to change the time on the computer. If we couldn't change it electrically, it means you wouldn't be able to do it through Windows. It means you'd have to go through some other, using some light or something like that. Cool. Okay, so this is all about storage. Storage is done. We're just going to briefly go into software. Operating system. What is the other name for operating system? Is this application software or system software? Roma? Yeah. So OS is system software. System software. It's the most important software on your computer. Okay? Tell me. In the class, we studied 3 different types of system software. Chad, tell me one type. When you first start your computer, there's different operating systems. You have an Apple computer, right?
Oh, Windows, Linux.
Correct. We have Windows, Linux,
iOS.
and iOS.
Yeah.
Correct. These are the 3 type of operating systems in the world. Uma, what operating system is the most common in the world? Windows. Why is Windows the most common operating system in the world? Why do you think that it's more popular than Apple?
Has a better user interface, right? So like it's more, it can be like edited.
Yeah, kind of. It's also, if you would compare the prices of Apple products versus Windows, what one's cheaper? Yes. So Windows is very cheap. And they actually started with MS-DOS with Bill Gates. You may have heard Bill Gates. Bill Gates used to be the richest man in the world. He started Windows with MS-DOS, Microsoft DOS. Okay? And basically it's for business, right? It's not too expensive. The majority of computers are Windows. Then the next are iOS. iOS, maybe it's more easy to use, right? Maybe easy to use. And Apple has made a custom thing. It's all about the look and feel of the product, right? But it's expensive, right? Sorry, the cost is cheap. This one, the cost is more expensive. Now we have a third one that we haven't talked about yet. What is Linux there, Ched? Linux is what?
Operating system.
Okay, and what is special about Linux?
It is very cheap.
Yes, it's so cheap. Do you have to pay any money for Linux?
No, don't need.
It's free. What do we call this, Uma? A free software. When we're talking about software, if it's free. Yes. This is called open source. What does open source mean? Can you give me some more details?
Free, and they give the code you can change.
That's correct. You can fully customize Linux, and Linux is used for Android on your phone. Okay? The majority of all phones in the world, including China, are using Linux. Okay? Banks are primarily using Windows, okay, for business. Graphic designers are primarily using Apple. Okay? So just note that there's some software types. Open source is an important key to remember. Okay, now we need to know what is some function of operating system. I want each of you to tell me one thing that OS does. Functions. What is the applications? What does it do? We need to get, what does the operating system do? Okay, Uma, tell me what is one function of an operating system? We need to be able to write at least 4 on the test. Okay, so tell me what is one thing that it does?
Provides a user.
Yes, it makes a GUI, graphic user interface. Okay, the user interface, it allows you to use the mouse, things like that. Mouse, and it has what do we call it? A display. Okay, you can click with the mouse and all that good stuff. Okay, Ched, the operating systems, Windows, Mac, Linux. What is one function they do? What does he do? What does Windows do? What does iOS do? What is some function? What is his job?
For operating computer.
Yes, I want more attention. Right here, for example, we have memory management, file management, user interface is already gone, security, error detection, networking, providing a platform for applications. Tell me one thing that the OS does. Is the PPT a little bit too small? Ched? What is this right here?
Memory management.
Very good. It's memory management. Very good. Wendy, tell me one application of operating systems. Tell me one application of what is the function? What does the OS do? We need to get at least 4. It provides a GUI, graphic user
File
interface.
management.
Yes. It's used for file management. File management. And last one, Uma. What is a function of operating system? Yeah?
The disk management or multitasking.
Yeah, very good.
All peripheral.
Yeah. We have this task management, multitasking. Yes. Task management. We call that multitasking. You can open up a game, you can open up to some music and watch a video at the same time. You guys love multitasking, right? Multitasking. Very good. As long as you know there's so many things there, I just put that, but you need to know at least for your test. Okay? Because operating systems are the most important. Okay, software, we've done that. Okay, now we're going into the hardware with the logic gates. Okay, I'm gonna go up. Okay, now we're on to logic gates. Wendy, what are logic gates? Can you name all the logic gates?
And or not.
Yes. So we have A, B. This is and. What is the symbol for and? What is the equation there, Wendy, for and?
0, 0, 1, 0.
No, the equation. The mathematical equation. The Boolean equation.
AB.
It's A times B. We say that's A and B, right? Then we have
Or
the or. It looks like a moon. This is called the or. What is the equation?
A plus B.
Okay. Then we have this guy here. What is this called there, Ched?
And no. Not.
It's called not. The symbol for not is a little hat. And then we have not. You can combine these, are called nan, that, and then there's the last one, the Uma. What is the last special gate, the unique gate?
Or XOR.
Yeah. What is the other name for XOR? It's called EOR, exclusive OR. Okay, he actually has two names. So we have A, B, and then this guy is called XOR and or EOR, either or. Okay, so just note he actually has two names. What is the symbol there, Uma? What is the symbol for an XOR gate?
Like this.
It's A plus B with a little O.
I see.
Yeah. Okay? You must be able to draw the gate. You must also be able to know his equation. Agree or disagree? And the third thing you must know is the... Wendy? You need to know to draw the diagram. You need to know his equation. And the third thing you need to be able to do is... A list, what we call it? Truth
table.
tables. Okay? Truth tables is where you have A, B. It shows you all the inputs and outputs. Agree? And then you just count in binary. The truth table for AND there, Ched. What is the output for AND's logic gate?
Oh, and if A and B both are 0, the result is 0.
Correct.
A or B, if one of it is 0, the result all being 0. If they are both 1, the result is 1.
Correct. These are things that you need to memorize. I don't give you these truth tables, but you need them when you're doing the equations, when you're doing the logic. And is only on when A and B are on. Very good. Okay, let's continue on. Let's do the truth table for the OR. Wendy, when is OR on?
0, 1, 1, 1.
0, 1, 1, 1. If one or the other one's on, it will be on. Very good. That's the OR. The NOT. We just have a single input and output, 0, 1, 1, 0. It just means to flip, right? Very good. And then XOR. Uma, what does the XOR gate look like? Or the EOR?
Like the not and the or.
Yeah, so just tell me the output. 0, 0 is?
0, 1, 1, 0.
It's 0, 1, 1, 0. Correct. You just think about only if one is on, it'll be on. Okay? If A is on, it'll be on. If B is on, it'll be on. But if both are on, it'll be off, or both off, off. Okay? Those are all the logic gates that you need to know. Okay? And you need to be able to draw the equation. You need to be able to draw the logic gates. You need to be able to know the equation. If I give you a diagram, you need to be able to make the equation. And then what is the last thing that you have to be able to do there, Wendy? You need to be able to draw. You need to be able to know the equation. The last thing you need to know is, what are these things called?
Truth table.
Truth tables. Truth tables. Okay, so please do review about that. This is just the things that you have to memorize is the data about that. Okay. Okay, we're on the last thing. Okay, the last thing that we studied was about the CPU architecture and assembly language. Okay, but assembly language is not hard because I give you the cheat sheets. I give you the equations to figure out what to do. Okay, so are we taking notes, Wendy? Wendy, you taking notes?
Yeah.
Okay, last thing is CPU. CPU for sure. On the final exam, CPU is maybe 20 points because the CPU includes the von Neumann architecture and assembly language. Okay, so it's about 2 pages. CPU, we have to talk about bus. Tell me, what is bus? Bus system, Uma. What is a bus?
It's for the it's on the motherboard
Yeah. What is the function of a bus system?
to move data.
Yeah. The bus system is basically a road for data. Okay? And we have 2 types of bus systems. One is 32X and one is called 64X. What does this mean there, Wendy?
It's like the bit rate of the CPU.
Not the CPU, we're talking about the bus. What does 32X and 64X mean?
The bit rate.
Yeah, it means the number of wires you have on the bus. And so if you have 64X, it means you have 64 wires. That means you can send 64 bits at one time. At one time. Okay? And we call the amount that you can send, we call it, does anyone remember? It's called a word. Okay? And so if you have a 64 word bus, it means it has 64 xian. Let's have a quick look inside the computer. Can you identify the bus?
Okay.
Can you see the xian? 有没有xian?
Is it
Bus. Where's the xian? Can you see? It's on the mobile.
on the motherboard?
You see the xian? 有没有xian?
Yeah, many.
Can you identify the bus? Okay, we're looking for like 64 wires. Where would the main bus be? Look at the RAM. Can you see it? Can you see the wires? From the CPU to the RAM? Can you see all those wires? Yeah. Can you identify the bus? Where's the CPU and RAM?
Little lines.
Yeah, show me the 64-bit system. Where's the RAM?
RAM is right here.
And then where's the CN to go to the RAM? Look right in here. Can you see all those little lines?
I see, right there.
Yeah, how many lines do you think this has? Can you give a guess? Is it 30?
64.
Correct. Today's computers have 64 xian. Okay? And there are 3 wires, control wires. The bus system has control bus. Control bus. What does the control bus do there, Uma? What is this? What does control bus do?
That moves the data.
Okay. Okay, what is his job? What does the control bus do? What does control mean?
Control the data.
Yeah. It's like a policeman. He says stop, go, and it tells you how fast. He has the clock. Or we call this the bus speed. We call this the bus speed. Okay? Clock speed. It's the speed at which data goes. Okay? And then we have the address bus. Wendy, what does address bus do? What does address mean?
Teacher.
Yeah, because we have so many things connected to the computer. We have USB, and we have keyboard. When I plug in this, I need to have a digit so that it sends to this device, not to the other device. Agree? When I put RAM, the RAM also has an address because we have to share the same road. All data goes on the road, but we can only send to one device at one time. Agree or disagree? Right? And so therefore, we need to say who the control bus will. We'll also have to say where's the data going to go. That's part of the control bus job. It's the address. And the address is measured in hex. For example, FF is an example of an address. And that's one specific device on the address bus. Okay? And then we have one more line, it's called the data bus. The data bus is like your 64 word wires that are used to transmit all the data. Okay? After I'm saying, hey, I'm going to talk to Ched, I'm going to talk to this device, I'm going to then send all the data.
Sir, this is covered the nodes.
This?
Yeah, covered.
Okay?
Okay.
Data bus is to send the data. It's to send the data. Alright. That is the CPU bus system. And then the last thing is inside CPU. Inside the CPU, we have the von Neumann architecture. Okay? And this was the last thing was the processor. And the processor has the function in the RAM, right? So, I'm going to CPU architecture about the von Neumann. I'm not 100% sure how to spell it. Von Neumann. Basically, inside your CPU, we have the CPU, yeah? And then we have the bus connected to RAM. Okay? In RAM, we have address. In RAM, we have data. And data, in here we can have two types of data. We have opcode and then operand. Okay? Opcode are functions like LDD, load data, right? Or LDI, or MOV. And the operand is the actual data. When we're talking about assembly, operand could have number 3. Number 3 means it's a denary number. Or it could say binary 1010. Or it could have a symbol FA. It could be hex. Okay? If it does not have a number, if it's just the number 3, or the number 64, this means it represents an address. And this is really important when we're talking about assembly language, about the CPU. Okay? The address is like number 1, 2, 3. This is kind of how they do it in the textbook on the exam. And then in here, they may say MOV, okay? And then they may have L, DD, L, DI, and then some number 4. Maybe this has hashtag 4, something like that, okay? You need to be able to trace through the assembly code, okay? This is the von Neumann architecture, and we spend a long time about that. So I'm not going to review too much about that. I'm just going to review a little bit more about inside here. We have the registers. What are registers? Wendy, what is a register? What is he? You can give some examples, but I want to know, what is a register?
Like the storage is the side of the CPU, and they have a very high speed.
Correct. Registers are the same as RAM. They're they're a fast, super fast RAM. Okay. Registers are fast RAM close to inside CPU. They're fast RAM in CPU. They're just for storage. Okay? And they're just like a biennial. They're just like a variable. They're a location around to store some data. Okay. Let's talk about the names of the registers. We have registers that do different things. What is the very first register? Is the PC. What is the PC? What does the PC store there, Uma? Yeah. And so PC is a program. And what kind of data does he hold? Okay, we're talking about count, but he's actually counting what? We start at a specific what? He's pointing to? Yes. So program counters store address. Write this down. The program counter is a PC is equal to PC plus 1. He doesn't store just one address. What address is he pointing to, Uma? It's a PC plus 1. What is he pointing to? Is it pointing to the current address?
The next instruction.
Yes. It's pointing to the next address. Okay? PC, it stores or points. He holds the next address. Next address. Okay? So you need to know what the PC, that's the very first thing. In the fetch, decode, execute cycle, the very first step is the program counter increments 1 pointing to the next address. And he's going to hold it. He's going to hold it there. What is the next part in the CPU cycle? So the very first part is program, the PC program counter. What is the next thing? Where does he give him to? Yeah, you can. What is the next step? What's the next variable? The next register.
Accumulator.
Look at the picture. After PC, we have MAR. The next step is the MAR. What does MAR stand for? Memory address. The program counter, I guess basically it's going to look like this. The PC is going to store in MAR. It means that the address that the program counter is going to save it to the address register. So let me just put the note here. What is MAR? Memory address register. Okay? Basically what's going to happen is the program counter, which is the next instruction, is going to Baoquan, it's going to be stored into the MAR. This is step 1, right? Step 2. Okay. What is the third register that we need to talk about? What is the third register inside the CPU?
MDR.
Yes, because inside we have the address check, but we also have the operand code, which has some data. We need to store that data in an address so that when we do the calculation, we can do it. So we need to, these are variables basically. The next is memory. Oh, let me change to black here. Memory data register. Okay. This is called memory data register. What does the memory data register do? It stores the data, the operand, from the RAM. Okay? We have the memory data register. He's going to, in the RAM, that data section. Maybe it's a number, maybe it's something else, maybe it's an address. Okay? So the data can be different things. It can be address, it can also be data. Okay? After I have that, after the memory data register stores the instructions or data, okay? This can also be, just remember, this is operand. Operand can be two things. This can be data, sometimes it's data, and sometimes it's the MOV instruction. This is the opcode and operand, okay? And instructions. So just remember, it's both. Okay, Uma, what is the fourth register inside the CPU? Yeah, because after you have your memory, your operand and opcode, we need to go to the current instruction register so that we know what the CPU knows what instruction to do. Am I going to move the data? Am I going to add? Remember how we have ADD and DEC, decrement and add? We need to have a variable called the CIR. Okay, so write this down, CIR. CIR stands for current instruction register. And it will store the current instruction. Maybe the thing is move, or maybe it's LDI or something like that. Okay, you have a list. Or maybe it's DEC. That will decrease the accumulator by 1. Okay, really cool. Now after that, after you have the instruction, what is the last thing? Wendy, what is the last thing? So we did MDR, PC, MART, CR. What's the last thing that the computer is going to do? We have fetch, decode,
Execute.
and execute. In execute, what is the execute going to do? Where's the data going to be, the final data of the program? It's going to be stored where?
Do the code.
Yeah, it's going to be in the, it's going to be in the ACC. It's called the accumulator. Another word for the ACC is the result. It's going to hold the result. The arithmetic result. And that's it. Okay. Do you remember all the assembly codes at the very last? I give you a little box called ACC, and you just have to figure out what number going to the ACC. It's called the accumulator. Okay? So that's the review. Okay, I got everything done. I'm gonna